students, today's agenda is to check homework. We'll be graphing radical equations and you will be able to do 5.5. Today's students will be able to graph radical equations by creating a table. Before we start, let's review the perfect squares. The square root of 1 is 1 because 1 times 1 is 1. Square root of 4 is 2 because 2 times 2 is 4. Square root of 9 is 3 because 3 times 3 is 9. Remember that the square root means find a number that multiplied times itself equals that number. And these are several of them. We'll be working mainly with these ones, but if you want to take a minute, pause the video and copy them so you can have them. Today's objective is to graph radical equations by creating a table, but I will also like to somehow apply using the mother graph and also seeing what the transformations are so that you can have both of them. So for the mother graph, you will always have y is equals to the square root of x. What that means is, and let me create a table. So you have 0, 1, 2, 3, 4. That will be the value of x. And we're trying to find the value of y. What does that mean? That we're going to substitute each value of x in here. And so the square root of 0 is 0. This y is equals to the square root of 1. What is the square root of 1? It's 1. Y is equals to the square root of 2. What is the square root of 2? Square root of 2, you just put the 2 and press the square root in here, and it's 1.414. So about 1.4. Square root y is equals to the square root of 3. So we press 3 and press square root. In some calculators, first you have to press the square root and then the number. Okay, so 1.7. And the square root of 4 is 2. Notice how we get decimals. So what you want to do instead is to find values of perfect squares, and that's why we reviewed those. So for x, you want to choose values that are perfect squares instead to make your life easier. So 0, 1, 4, 9, 16. Okay, that way when you substitute the x with these values, the square root of 0 is 0. The square root of 1 is 1. The square root of 4 is 2. The square root of 9 is 3. The square root of 16, let's not go that far. It's 4, but you're not going to be able to graph 16 in this grid. So, okay, so that's my mother graph when you only have y is equals to the square root of x. So 0, 0, 1, 1, 1 on x, 1 on y, 4, 2, 4, 2 is right there, and 9, we don't even go that far, but it will be 6, 7, 7, 8, 9, somewhere in here if we were to extend it. So that will be our mother graph. But if you subtract 2, that means that it will go down here. If it's outside, it just goes down. It goes down 2 spaces. This goes down 2 spaces. This goes down 2 spaces, and this goes down 2 spaces. That will be my new graph. Now, that's just using the transformation that we see here, but let's use our table so that we can find those values. Let me write the equation again. So it's the square root of a number minus 2. So this is when these values come in handy. So have them in front of you. Whenever you have only x inside of the square root, it's okay then to use these perfect squares, including the 0, of course. So 1, 0, 1, 4, 9. And I think we'll do just up to 9. Then we're going to, what this means is replace the value of x and take the square root of that, then subtract 2. So y is equals to the square root of 0 minus 2. And that's equals to the square root of 0 minus 2, which gives us negative 2. So 0, negative 2. This is the value for x, this is y. For the next one, y is equals to the square root of 1 minus 2. The square root of 1 is 1 minus 2. 1 minus 2 is negative 1, so that's the value for y. Let's do the other one in here. Y is equals to the square root of 4. Again, I'm just substituting the x with that value and bringing down the negative 2. The square root of 4 is 2 minus 2. And so 2 minus 2 gives us 0. So the value for y is 0 when x is 4. For the last one, again, y is equals to the square root of x. X is 9. Bring down the minus 2. The square root of 9 is 3 minus 2. And 3 minus 2 is 1. Now, we're going to be going back and forth, but 0, negative 2. It's right there. 0, negative 2. For the next value is 1, negative 1. If you notice, you go 1 on x, negative 1 on y. The next one is 4, 0. 4 on x, 0 on y, so you don't go up or down. And the last one, 9, 1. So you go 9 spaces on x, 1 on y. And so again, you can just use the mother graph and then say, oh, you're just going to bring down the whole graph or the mother graph 2 spaces for each point, or you can just create the table. Again, the focus in here is not to go over the mother graph and do its transformation, but it's just good review and so that you can see it. Again, the mother graph will be at 0, 0. I'm just using this table, 0, 0, 1, 1, 4, 2, and 9, 3. So somewhere around here. And so that's my mother graph. Whenever you see this, when you're adding something inside, that refers to x. And if you're adding, it goes to the negatives. And that's because you're months ahead or values on x ahead. So that's why the graph goes backwards or to the left. Not only that, but this negative means that it's a reflection on x. A reflection on x. So if you were to see this, you would go 1, 2, 3, 4. This point will go 4 points to the left. And because it's a reflection on x, this is a reflection on x, it will go, instead of like this, it will go down here. So notice how you have 1, 1. So 1, 1 is right here. Then from this point of the origin, it goes 2 spaces up, 4 to the right. So since it's a reflection, this is going to go 2 spaces down and 4 to the right. And finally, this one is 3 spaces, 9. So from here, 3 spaces and then 9 spaces over here. So that will be my reflection for the new graph. Now let's find it with a table. So y is equals to negative square root of x plus 4. Now that's my equation so that we can see it easier. Something that we need to know is that we need perfect squares under the square root or the radical. That means 0, 1, 4, 9. Again, we're just going to go up to 9, but those are not the values of x, because if you put, let's say, 1 plus 4 is 5. It's not easy to get the square root of 5, or you will be getting a decimal, and we want those points that are exactly on intersections, right? Because if you replace the 1 in here, 1 plus 4 is 5, and the square root of 5 is 2.2, and more decimals. So what we need is perfect squares. We need to figure out what number would be x. What would be the value of x to make those perfect squares? So in here, to make this a 0, well, if I have 4, that means that I need a -4 for x. Because -4 plus 4 will give me that 0 that I need underneath the square root. If I need a 1, well, 4, I need to subtract 3. So -3 will be the value of x. -3 plus 4 is going to be 1. If I need a 4, well, 0 plus 4, so the value for x needs to be 0. That way, when I replace 0 plus 4, will be 4. To get a 9 underneath the square root, well, I have 4. That means I need 5 more. 5 plus 4 is 9, and the square root of 9 is 3. So that makes our lives a lot easier. And now we can just start finding the values of y by replacing the value, not this one, but this one right here. Y is equals to negative square root of x is -4 plus 4. We bring down the negative. The square root of -4 plus 4 is 0. Bring down the negative, and square root of 0 is 0. 0 is not positive, it's not negative, it's just neutral. It doesn't belong to any of the two sets. So this will be 0. For the next one, now x is, don't get confused with this ones, okay? Maybe just scratch them afterwards. Now it's going to be -3. So negative square root of, the value of x is -3 plus 4. Bring down the negative outside. Square root, -3 plus 4. Well, because they're different signs, we subtract and leave the greater sign. 4 minus 3 is 1, and the greater sign is positive. So y is equals to, bring down the negative. The square root of 1 is 1, so it's -1. For the next one, x is 0, so y is equals to the square root of x is 0 plus 4. Y is equals to, bring down the negative. 0 plus 4 is 4. Bring down the negative. And then the square root of 4 is 2, so -2. And then the final one I'm going to do right here. Y is equals to negative square root of, the value of x is 5. 5 plus 4. Y is equals to, 5 plus 4 is 9. Oh, but don't forget to bring down the negative. 5 plus 4 is 9. Bring down the negative. Square root of 9 is 3. And so that will be -3. Now I want to show you that if we graph this, -4, 0. -4, and then we don't move up or down because it's 0 on y. -3, -1. -3, -1 is right there. 0, -2, 0 on x, -2 on y. 5, -3, 1, 2, 3, 4, 5, 1, 2, 3, -3. And so that's my transform graph using my table. For number 3, it's a little bit more tricky. Let me write it down here. But not impossible, of course. Again, we need, for x, we need 0, 1, 4, 9. And so what we want to do in here how do I find this value? So I'm going to use another piece of paper just so that I can show you how to find that value. Whatever is inside of the square root, negative 3x in this case, you just equal it to whatever you're looking. And we know that negative 3 times 0 will be 0. So we can just say, oh, for the first one is 0. Okay, for 1, again, we are going to put this that is inside of the square root equals to 1. We divide by the coefficient by negative 3, and so x is equals to negative 1/3. And so that's the value that we need here for x. For the next one, you need 4. So again, get whatever is inside of the square root, which is negative 3x, equal to whatever you're looking for. If we're multiplying, the opposite is to divide. And so we get negative 4/3. And for the last one, you need a 9. Negative 3x is equals to 9. We divide by negative 3. And so x needs to be 9 divided by negative 3 is negative 3. And that way you find values that will make it easier. Now substitute to find, so y is equals to the square root of negative 3 times the value of x, which is 0. And negative 3 times 0 is 0. Anything multiplied by 0 is 0. And the square root of 0 is 0. For the next one, y is equals to the square root of negative 3 times the value of x, which is negative 1/3. Whenever you're multiplying a whole number times a fraction, you just multiply like this. The whole number needs to be multiplied by the numerator, and then the result is divided by the denominator. That you can do also canceling, but it's just 2. Negative times negative is positive. 3 times 1, 3. 3 divided by 3, 1. See, that's how we got to that 1 in there. And the square root of 1 is 1. For the next one, y is equals to the square root of negative 3 from the equation times the value of x that we found to make it nicer. And so again, negative times negative will give me positive. And 3 times 4 is 12. 12 divided by 3 is 4. Again, you could have just canceled the 3's. And so negative times negative is positive 4. The square root of 4 is 2. And finally, y is equals to the square root of negative 3 from the equation times the value that we found. And so negative 3 times negative 3 is positive 9. The square root of 9 is 3. And now we have our values to graph in here. So 0, 0 is 0, 0 is right here. Negative 1/3, 1. Negative 1/3 is around here. Positive 1 is right there. Negative 4/3 and 2 for y. Negative 4/3 is the same as the 3 goes into 4. Well, it's negative. The 3 goes into 4 one time. And 3 times 1 is 3. 2, 4 is 1 left. And you just bring the... So it's negative 1 and 1/3. Negative 1 and 1/3. And the value for y is 2. It's right there. And finally, negative 3, 3. So negative 3, positive 3. It's right there. Now, if we were using the Mother graph, you have this point, 4, 2, and then 9, 9, 3, somewhere around here. Okay, that's my Mother graph. So how does this transform this to this? What it's saying is that this is going to, if it's inside, a 3 compresses it. okay, by 3. So in the negative, it's a reflection on y because it's inside. The negative outside is a reflection on x. The negative inside is a reflection on y. So let me show you how each one of them compresses. So in here, it goes to 1. If it was just a reflection, this point would be here. But then it says that it compresses 3 times compressed. So that's why it goes to 1/3. The 4 would be right here. It compresses to 4/3 right there. Inside is like going 3 times faster. So instead of going from here to the 9, 3 times faster, it goes back to 3. And it's not 3 less, it's 3 times faster. And so what that means is that this, if it was just a reflection, it would be something, this reflection would have moved this graph right here. -1, 1. +4, 2 would be -4, 2. And +9, 3 would be -9, 3. Something like that, okay? But then the 3 makes a compression. It says that it's 3 times faster. So that's why it goes here to 1/3. Because if instead of taking 1 month in the past, it took only 1/3 of the month. Okay, is instead of taking 4 months in the past, it's just 4/3 of that. And instead of taking 9 months, it took only 3 months in the past to get to the 3. So I know that that one is a little bit more tricky. Maybe with the table it's easier, even though it's a little bit more work. Okay, for number 4, let me write it here, and I also create the table. Okay, so these are the values that we need. And guess what? Since there is nothing else but x inside of the square root, we can actually use those values. We don't need to put them on the side. Okay, and what we do is just bring down the 2 and then replace the value for x so that we can find y. So x is 0. That means it's 2 times the square root of 0 is 0, which is 0. 2 times the square root of 1. 2, the square root of 1 is 1, and 2 times 1 is 2. The next one is 4, so y is equals to 2 times the square root of 4. See, when only x is inside, it's a lot easier. You just bring down whatever is outside and then get the square root of those perfect squares. Square root of 4 is 2. And 2 times 2 is 4. And the last one, y is equals to 2 times the square root of the value of x, which is 9. The square root of 9 is 3. And 2 times 3 is 6. And now we're ready to graph those. So 0, 0 is right there. 1, 2, 1, 2 is right there. 4, 4, 4, 4 is right there. 9, 6, 9 is somewhere about there. And that's my graph. When you're multiplying by 2, our mother graph was here, 1, 1, 4, 2, and 9, 3, somewhere in there. That was my mother graph. How does this compare to this? What this saying is stretch, a vertical stretch. And that's why it stretches twice as much. If it was a 2, when x was 4, y was 2, so it stretches to twice as much. Instead of 3, is 6. So in here it's just vertical stretch, it's a stretch on y. In here, it was a compression on x, so it makes it compressed. Again, you can use the table or the mother graph, or ask your teacher to see what he or she prefers. Okay, this is the equation right here. To save time, I already wrote it down. Remember that if there is something else going on inside of the square root, we will need to have these values to make it easier for us. So again, you can just kind of mentally figure out, okay, what do I need in here to make it 0? Well, if I have a positive 1 minus 1, that will give us 0. So the x needs to be 1. But if you're not sure, just do the tiny equation. Get whatever is inside in here and make it equal to the number that you need. Then you just say, okay, if I'm subtracting 1, add 1 to both sides. And so x is equal to 0 plus 1, 1. And that's the value of that we need for x. For the next one, again, get x minus 1 equals to the number that you need. And here, if we're subtracting 1, we add 1. And x needs to be 2 to make it a 1. Or you can just look, okay, what do I need to make it a 4? Well, I need a 5 because 5 minus 1 is 4. So this needs to be 5. 5 minus 1, 4. Or again, you can just say, okay, x minus 1, which is the expression right here, equals what you need. Add 1 to both sides. X equals 4 plus 1 is 5. And then if I need a 9, let's do it first mentally. Okay, if I'm going to be subtracting 1 and I need a 9, then that means that I need a 10 because 10 minus 1 is 9. Or again, you can just create the equation. X minus 1 equals 9. I add 1 to both sides and x will be 10. Okay? Y is equals to, I put 0 minus 1. What did I just do? I got this value, scratch them so that we don't get confused because this is what we're going to be substituting. 1, which is the value of x, minus 1 is 0. And the square root of 0 is 0. For the next one, y is equals to the square root of 2 minus 1. The square root of 2 minus 1 is 1. And the square root of 1 is 1. Y is equals to the square root of 5 minus 1. I take the square root of 5 minus 1 is 4. And what is the square root of 4? Is 2. And finally, y is equals to the square root of 10 minus 1. Y is equals to the square root of 10 minus 1 is 9. And y is equals to the square root of 9 is 3. And so now that we have those values, we start graphing 1, 0, 1, 0 on y right there. 2, 1, 2, positive 1, 5, 2. So 5 on x, 2 on y, and 10, 3. 10 will be 6, 7, 8, 9, 10, somewhere in here, and then 3. Okay, we're going over the other graph. Now, if we were using the mother graph, which is this one right here, 4, 2, and 9, 3. What this says is that whenever you're adding or subtracting inside of the square root, we are going to move our mother graph one space, but to the opposite. If you're subtracting, you're going to the right. If you're adding, you're going to the left. But that's only inside of the square root. You saw in the first one, number 1, that the addition or subtraction was outside. That's going up for positive or down for negative when it's outside of the square root. Okay, subtracting or adding outside of the square root, up or down, depending, and that one does follow the sign. So negative goes down, positive goes up. But if you're adding or subtracting inside, then the graph will go on X and the opposite. See, -1 is going to the positives, one space from the mother graph, one space to the right. So let's do this one first, the mother graph. The mother graph is at 0, 0, 1, 1, 4, 2, and 9, 3. That's my mother graph. That means that if you're adding 6 inside, it will go, each point will go 6 spaces to the left. So 1, 2, 3, 4, 5, 6, right there. 1, 1, that's 6 spaces to the left, right there. That one 6 spaces to the left is right there. And that one is 6 spaces to the left, it's right there. Okay, that's where our table value should give us. Let's check. Okay, we need the values 0, 1, 4, 9. You can do the little equations on your own. Just put x plus 6 equals 0, x plus 6 equals 1, 4, and 9. Okay, you can just see, okay, if I need a 0, -6 and the positive 6 will make 0. To make it a 1, I need -5. Why? Because -5 and positive 6 will be 1. To make it 4, well, I need 4 of these. That means that I need to take away 2. Or -2 plus 6 is positive 4. To make it 9, I need positive 3. Because positive 3 plus 6 is 9. But again, if you can easily find those values, just create equations, okay? X plus 6 equals each one of those numbers. Now that we have the values for X, cross it out so that you don't do the same mistake that I almost did in here. So it's going to be Y is equals to the square root of X, which is -6 plus 6. Y is equals to -6 plus 6 is 0. And that's 0. Y is equals to the square root of -5 plus 6. All I'm doing is substituting that value of X with the values that we found in here. Y is equals to the square root of -5 plus 6 is positive 1. Remember that we subtract and leave the greater sign. The square root of 1 is 1. The next one, Y is equals to the square root of -2 plus 6. Y is equals to the square root of -2 plus 6 is positive 4. And the square root of positive 4 is 2. And finally, Y is equals to the square root of X is 3 plus 6. The square root of 3 plus 6 is square root of 9. And the square root of 9 is 3. So now we have the values for our graph. And we already have the graph because we just did the mother graph and then the transformation. But let's verify. -6, 0. -6, 0 is right there. -5, 1. -5, positive 1 is right there. -2, positive 2. -2, positive 2 is right there. And positive 3, positive 3, positive 3, positive 3 is right there. So that's the transformation. And we did it both with the mother graph and also with the table. Ask your teacher if either one is okay or if they prefer to see the table. With this, we end our lesson. If you can please support our channel by giving us a thumbs up, subscribe around here. This is the link to the entire unit, and this is the next lesson. Now you're able to do 5.5 and have fun.